So the graphs of y equals f of x and a new graph where there's been horizontal and vertical stretches or compressions is shown. We have to figure out the equation. And I'm going to do this question in two ways. We're going to do an easy way first that I think will make total sense for you. But
Hi, Mr. Jackson-Rowe.
hello?
Hi, so sorry to interrupt. Could you just do your attendance, please?
Oh, sorry about that.
That's okay, thank you so much.
Oh, I got in trouble. You can get fired. All right. So the easy way to do this question is this idea. Oh, thank you. The easy way to do this question is now the original graph and the final answer are given to you. You have to think about, well, what would we have done normally if we had to work backwards? Normally what you would do is you would say, oh, I have some points on my original graph. For example, on my original graph, I had the point 3, 9. I also have the point, I'll just do two of them, 2, -8. And then something happens, and normally we write what we need to do, and then we find the point, but since we already know where they go, we know that this one's going to 1.5 and 4.5, and we know that this point goes to 1 and -4. We're given the final answer. What we're not given is what happened here. What did happen there? Is there a way that you could go to 3 to 1.5? What would you have to do to x? Right? You'd have to multiply it by 1/2 or divide by 2. Does that work for the other one?
Yeah.
Yes. What about y? Also divide by 2, right? Did that work for the other one? Yes. So if we think about what we did in our other question, now we're just working backwards and we're filling in the information we don't know. Well, if I know this information, I can now write, and we'll write it in blue, because my equation's in blue. Well, if y by 1/2, that would be outside the function, right? And y's aren't liars, so I'm just going to have 1/2 outside the function. Then I'd have my function f, because it says in terms of f, so I need to have f on the other side. And x by 1/2, x's are liars. So what am I going to have inside? A 2. Okay? This is the best way to do this in this situation. Later on, we're going to have questions that have both stretches, compressions, and translations afterwards. So we're going to also do this as another technique. The other way that you can find out the 1/2 and the 1/2, this is the easiest way, but later on you're going to have to do this. You're going to have to compare horizontal distances. So I'm going to take out my red pen, and you're going to pick 2 points. So I'm going to pick point, I'm going to call this point A, and this point B. Then on our image graph, what we often do as a label is we put A with a little dash, A prime, and B with a little dash, B prime. So we're going to compare the horizontal distances from A to B, and compare it on the blue one from A prime to B prime. From A to B, if I go from A to B, it looks like I go 1 unit to the right. So I'll put a +1 there. If it was 1 unit to the left, I'd put a -1. Does that make sense? If I go from A prime here to B prime, now that is only 0.5 units to the right. How would I change that? I would have to multiply by a half. Much easier to see with the points right at the beginning. I totally agree. But later on, we'll have to use this strategy. Okay? What do you think we're going to have to do to find what happened to y? We're going to have to compare vertical distances. We'll do that as well. Again, on the red graph, if I go from A to B vertically, can you see that you would be going up 8 and 9, up 17? Maybe I'll put a plus sign there. I like that idea. Just to show that we went up or right or left. And then A prime to B prime. Now I'm going up 4 and 4.5, up 8.5. From here to here, I would have to multiply y by a half as well. So right now, I think the first strategy, easier to see, easier to understand because it's really working backwards. We're going to run into a problem with working backwards in the next section, and this strategy is going to help us more. So I introduce it to you already. But for all your homework, feel free just to use strategy number 1. Oh. Okay, 5, 12, 13, and 14.